The culture of high performance can only be built with a stable supply of new values and their clear division. Elite teams can deploy the code up to 10 times a day, while worse teams can work on releases for over a week. You can't deploy the code fast enough if testing is done manually. What if I told you that there are simple metrics that can show you the evolution and the state of your IT team? At least two of these metrics are very simple to compile, and they're simple to explain to anyone, starting from the procurement and finishing with the technical team. These metrics are also the result of many years of research supported by Google, Amazon, GitLab, and a dozen other IT companies. The research book was even awarded by the famous Shingo Publication Award. Let's welcome Dora. Dora, Google Assessment Method. Hello everyone, I'm Andrey Putin, and today we will talk about how teams of developers can objectively understand their own quality. Today the whole IT industry is in the search process of best practices. Therefore, today the notion of metrics can be confusing to many. There are still engineers who believe that performance speed is inversely dependent on code quality. There are still managers who assess team productivity using burn-down charts or by counting coded lines in Git. And on top of this, you're usually being told that these are very important, very loaded, very complex, and very special services, meaning that quality must be in first place and the work needs to be done well. I have already referred to the book Accelerate, whose author, Jess Humble, won the Shingo Prize. And today, we will try to touch on an important part of all the research done and on what we have all come to over the past decade. First of all, a little background. Questions about performance quality assessment and team productivity are not new. However, assessing team efficiency simply using business metrics is often complicated. The culture of high performance can only be built with a steady supply of new values and their clear division. But even that won't guarantee a result, because system analysis says that the result of actions can be nonlinear. Many actions may not be explicitly related, and the Canadian framework states that causalities may be known in retrospect. So it's the chicken or the egg causality dilemma. In order to learn, you need to get feedback on planning, and to plan, you need to gain knowledge in framework. So where do we get such knowledge? Changes in the number of lines of code are not a suitable indicator. Story points and burn-down charts are often deceptive because these are all subjective indicators. The team has to show more lines of code? Well, okay. You will get meaningless lines that will only complicate further support. You want to use story points? The team will assess values in a way that your chart will grow. Yesterday, the green command button was rated at 8 story points. But in this race, do you need to show growth? Here you go. Now the green button will be rated at 13 points. Progress? Are you considering the burn-down chart? There are also a lot of details about switching commands, sharing values, and other stuff. So the burn-down chart will show the sum of efforts of the technical team and the management, where you can also have many manipulations. The burn-down chart has been discussed so often that it seems necessary to make a separate video about it, but let's not talk about it today. Fortunately, IT has a lot of data thanks to automated code layout and integration systems. Such data, combined with various surveys, make it possible to draw statistically significant conclusions, and that is exactly what the majority of American researchers used. IT giants sought clear insights and correlations to understand how to better organize their technical teams. Many discoveries were made during these studies. For example, that a team of 32 developers writes as much code as a team of 4, but 5 times worse, almost 10 times more expensive, and only 11% faster. Or that the most effective teams are not those with highly skilled developers, but those with a good information flow within the team. Many misconceptions, such as the one stating that only strong developers are needed, were exposed, but still, there wasn't any clear and simple metric reflecting this. And only in 2013, 3 companies including Puppet Labs, who remembers Puppet, revealed that quality positively correlated with speed. That is, the faster the teams were, the higher was their quality of work. How is that possible? So many teams have argued that they need to check everything properly, that they need to think about everything carefully, and that a testing department is needed. Managers will remember those projects of implementing some ERP system that could go on for years. But with all the data in hand, is it all evidence of bad quality? Researchers teamed under the name DevOps Research and Assessment, which is abbreviated as Dora. The team had very serious intentions. After all, they were already numbers from Puppet, a tool for automated software deployment. They asked businesses about their market share, their speed of delivery, and their profitability. They wanted to prove the success of DevOps practices, but the result exceeded all expectations. After analyzing 9,200 survey responses from 110 countries and the data from Puppet, in 2014, Jess Humble published a report called 2014 State of DevOps Report. According to Martin Fowler in his foreword to Accelerate, the reason why he didn't toss into the rubbish the report that said that high IT performance correlates with strong business performance is because he personally knew Humble and because he was reading it on his iPad. That's usually a tell for some bogus bullshit. The study covered all industries, even those that considered their slowness to be justified. For example, the financial sector. Banking and finance represented 7.5% of companies. More than 5% were from the public sector and 3% from healthcare. These are good numbers. After all, 1% represented over 90 companies. In their first study, more than 40% of companies had over 500 employees, and more than 70% of companies managed over 100 servers. So the sampling was done well. There was a lot of big businesses and there were also smaller teams. The teams used easily collectible data, such as the number of releases and survey responses. The result was what is today considered to be the key to understanding the effectiveness of IT teams. So what were the conclusions? The first thing that came up is the relationship between the number of failures and the number of releases. The best team deployed the code 30 times more frequently and failed 50% fewer. Based on 2019 reports, elite teams had 106 times faster change lead time from commit to deploy, and change failure rates were 7 times better. After searching different data sets and detecting correlations, 3 metrics were obtained. The first one is deployment frequency, which is how often new code is deployed into production. The second one is lead time, which is the length of time between when a code is committed and when it is deployed. And the third one is mean time to recovery, which measures how long it takes to recover from a partial service interruption or total failure. In 2014, there was a fourth metric, change failure rate, which is the percentage of code changes that require hot fixes or other remediation after production. However, the authors did mention that they didn't find a strong correlation between the practices and this metric, but there was a strong correlation between good and bad teams. In 2019, an additional metric was added, availability, meaning the ability of teams to keep up the service fully functioning and accessible. Now, let's go through each metric one by one. Deployment frequency is a perfect metric that is very easy to deal with for absolutely any department. Elite teams deploy the code up to 10 times a day, while the worst teams can work on a release for over a week. So based on the study, what practices correlate with this metric? You won't be able to deliver frequent releases if you do not follow the always releasable state practice. Your code must always be ready for deployment. When everything is working from one commit to another, you can deploy the code automatically after each commit. The speed will increase because the versioning system is used not only for the versioning of the code, but also for all the artifacts that allow you to deploy the system anywhere for debugging and troubleshooting. Lead time is the length of time between the first commit and the release. It is also easy to deal with, though it is more technical. It is not as easy to compile as deployment frequency, but this task is easily solved by a simple report from GitLab. That is, if you have the ultimate subscription. We use a specialized service called Sleuth. There are quite a lot of other similar services. Elite teams can do this work in under an hour. For good teams, it takes from a day to a week to deploy code changes, while for average teams, it can take from a week to a month to do this work. For worse teams, it can take up to 6 months to deploy code changes. What are the main correlations between this metric and the practices? In addition to the already mentioned full use of the version control system, automated testing is very important. You can't deploy the code fast enough if testing is done manually. In another video, I have already said that you shouldn't be hiring QA specialists. It is absolutely obvious that teams that deploy the code within an hour would not even see the start of testing if it was to be done manually. Mean time to recovery. It should be noted that if elite teams can fix release errors in less than an hour, good and average teams can do the same work in less than a day, bad teams can work on restoring functionality for a week or more. Imagine how this kind of work affects motivation and job satisfaction. After all, if you take into account the number of failures in bad teams, it turns out that most of the time they spend on recovering. This in turn makes the teams do less because their workload increases and they become reluctant to deploy new features. Each release becomes an event for developers in such teams. Of course, this leads to slow feedback from users and to a lack of resources. Businesses are forced to moderate their appetites by their IT infrastructure rather than by business requirements. Dora points out that this metric best correlates with the strategy of feedback collection from the system itself, through logging and monitoring with the use of proactive signals such as an alert if some metric typically decreases or increases, and of course, through the use of a versioning system. I've already been cursed for my opinion on QA. Well, here's another reason for you to hate me. If you hire some specialists to do content view, and in general, if your feature branch exists for more than a couple hours, both the time for deployment and the time for recovery will suffer. So, my friends, don't branch. This is very important. Change failure rate. If you release frequently, you will often have failures, right? That's not true. According to the research, best teams have at most 15% failure rate during releases. And those are peak values, while the worst teams have failures in at least 46% of deployments. This metric is more difficult to collect because bad teams can include in one commit both fixes and parts of the new functionality. Therefore, without introducing rules on how remediation should be marked, it may not be easy to compile this metric. I can tell you one thing for sure: if you see a steady 0 in the GitLab report, it means that your team is not using Git properly and you need to start with the basics. As you can see, these metrics are nice and clear, and the first two are easy to deal with even without organizational changes. This study has been repeated many times. The conclusions have only been reinforced. It should be noted that it provides statistically significant evidence of the importance of each practice and allows team leads to develop their own, given the fastest possible impact on improvements. Dora notes that performance quality metrics are overall increasing, but they're increasing non-linearly. In retail, for example, in recent years, the culture has become much higher. The quality of financial technologies is also growing. However, other sectors have seen much weaker growth over the years. My friends, we have a lot of work to do. I didn't really want to discuss this topic because it is too technical, but every time I bring it up during some business meeting, there are always a lot of questions about it. That is why I came up with this video. I hope it was interesting. Thank you for your time. Bye.